Okay, let's give a brief introduction to IRSIM and ALS. ALS is asynchronous logic simulator, and IRSIM is a switch level simulator where MOSFETs are replaced with resistors, switches, and capacitors. So we'll save our library as, file save as version 12. Do a control N. We'll do a quick little sim, IRSIM1, and it's a schematic. And we need to use the elements that have transistors, so we'll go select an inverter, just throw it in here, fit, zoom out a little bit. Let's throw down a capacitive load, press Control till I get to that. Control I, 100 femto, drop in my ground, come up here, fold it over, then drop in a few off-page nodes so we know what we want to plot here. And zoom in and pull those over. Do Control E. This is an input. Let's call it input. And in. And we'll do a Control E and export this one. And this is output or out. Then we're ready to use IRSIM now. And so we'll go ahead and save. Then simulation built in, and in older versions of Electric you had to load this as a separate plug-in. In the newer versions it might be included so you don't have to load it, but in any case we'll just go simulate current cell. Notice we didn't put power supply or whatever. That's in the IRSIM setup file, but you can find out more about that in the manual. So we run this, and let's hit tile. And we'll take, and let's go ahead and increase the width of these. And we'll take this time right here, and this is my main time. I'm going to move it all the way back to 0. And then I'm going to go here, Tool, Built In, at main time, set signal to ground. So that's what I'm going to do. I'm going to set that signal to ground. Oops, I guess I got to select it first. Set main time set, or press G, and now notice I can press V as well, so I'm going to use those two keys in the next few seconds. So press G, then I'm going to pull that trace out a little bit, and I'm going to press V to drive my input to high. Now this is my output. Why that's not showing as output, I don't know, but it is the output. I pulled it down. I can go take a look at my signals there if I want to, and then they highlight on the node. And then I can go over here, and if I press G, I've got to select the signal again, don't want the error, it'll drive my input back to ground. And you can see there's a certain delay. Now a couple of things. When you're doing a complicated logic schematic, you might want to save that simulus to disk or restore it from disk. So once you've got a set of inputs, you can save them. I don't think you can set a clock signal in IRSIM, but let's try it. Oh, I guess you can. Alright, so let's see what happens. I don't know what that is. Let's see, that's 3, that's 10 nanoseconds. Why don't we, yeah, 10 nanoseconds is good. Okay, so it says cannot handle clocks yet. Alright, that's fine. We can keep going and drive this to V, etc. Now, what's going to happen if I go here, do a Control I on that, or let's select the value rather, using Control I, and I change the capacitance to 1000 femto or 1 picofarad to the delays. Well, if you look at the time delays here, they're going to get longer. So if I resimulate now, you're going to see the time delays move out. Oops. Looks like they've moved out so much you can't see them. So let's just type G, V, and now, and so forth. G, and the delays have pushed out. Let's do it again on this one. Let's go back here. I think I've used too big of a capacitive load. Control I, and let's change it to 10 and see a smaller delay. Okay. And then resimulate this. Simulate. That's my input. So let's drive this back and press G. That's my output. Drive this back and press V. Oops, wrong one. Let's drive this one up. Oops, I'm getting too many windows here. And it doesn't, I think the reason the names aren't showing up correctly is I'm on such a low resolution display. It's thinking that it will distort the names instead of displaying it correctly, so it just puts the ... there. Anyway, oops, that's not the one I want to move. I want to move that one. So let's move that back to ground. Anyway, you can see the delay is smaller there with the simple IRSIM simulation. All right, so, and you can put different logic in here and run the simulation and move it and all that. So let's close this, save, close this, do a Control N, and do a schematic, and let's do an asynchronous logic sim. Let's call this _1. Okay. Tile and components. Now here we don't use our cells that we've had that we've developed. We're going to use generic cells. We're going to use an inverter like, or a buffer like seen right here. And we'll just do something real simple. And we can throw down our off-page nodes. Here, fit, coming in, left click and drag, coming in, there. Now I can export this one, Control E, and this would be an input and in. Notice these aren't inverters, they're just buffers, and then this will be a Control E, and that's an output, and let's call it Y just to be different. Now if I want to change these to an inverter, I select the port and I can type Control T for toggle. So if I go back, let's see, that's in where is that? Technology specific toggle port negation Control T. So if I go back here, I select this and I go Control T, changes it to a regular arc. So I save this, and now I'm ready to use a logic level simulation. Notice I can't push down in here, so if I do Control D, nothing happens. So I save this ALS. I'm going to come back now and do simulation built-in asynchronous logic sim. Before I do that, look at the Explorer. Here's my ALS. Now watch what happens. It's going to become a group when I go do the simulation here at the logic sim. So I go simulate current cell. If I look now, there's a VHDL view of this cell, pretty simple. And then there's the net list for the asynchronous logic simulator, which is seen right here. So if I go back, there's the cell. I press tile. Let's look at the input, and these are the intermediate nodes. So I'm going to go ahead just like I did before. And let me make this bigger so it's easier to see. And I'm going to slide this down, press G, tool, built-in, set signal low at main time, G, oops, got me, G, drag it out, press V, and it's a buffer so it shows just the delay, and then I can drag it out a little bit more, and I can make and this VHDL simulator ALS, I can then put a clock, and I could go 10 nanoseconds, okay, and then there's my clock signal, etc. I can tile this, and I can look at the different signals that go through and vary them. And then again, if I want to save the simulus, I can go over here and store, save simuli to disk, and then restore it. And so I can do, a logic level simulation using the blocks that come that aren't transistor level, but just to verify that things work correctly. And also, I can go in and Verilog and set for the simulator the transistor strength and do all the other normal things you can do with a hardware description language. Okay, so let's quit.